All right, just as a quick reminder, this is what you guys did on Friday. We talked about the side angle side case with law of cosines, which is what we also just did on your bell ringer, where you had two sides and the included angle, and you were trying to find that side that's opposite of that included angle there. And so we talked about the different ways that we could write law of cosines and how it doesn't really matter maybe what side's missing. You can like kind of make your formula work for you depending on maybe what side you're trying to miss. So we talked like on our bell ringer, we were solving for that side across from angle A, so we called that little a. On this one, we solved for B. We could also solve for side C if we needed to. Okay, so this is what you guys did on Friday. Now, today we need to talk about this other case, which is the side case. This is also one of those situations where law of sines did not work. I can't just set up sine of an angle over a side is equal to another sine of an angle over another side, because if you guys look at this picture, are there any angles given to you guys? No angles. So if I try to use law of sines, I'm going to have like sine of A over, in this case, it'd be 15, and then sine of B over 25, or sine of C over 12. I'd have two variables in my angles, and I'm kind of stuck. So that's why we can't use law of sines. We have to still use law of cosines for this case. If you guys remember when we did law of sines, we did talk about the case of if you were trying to find an angle on law of sines. So that's what we're going to do, but we're going to be finding an angle using law of cosines today. So they want me to figure out, for just this picture here, what angle B is. So they're kind of isolated, and they're not saying you have to find all the angles in the picture. We could do that, or they might say solve the triangle, then you have to find everything that's missing. But for right now, they just want me to find angle B. So if you're finding angle B, that means that when you think about law of cosines and you're trying to set up your formula, you want to start with the side that's across from the angle. Because remember, those things still correspond to each other in your formula. The side that you start law of cosines with needs to line up with the angle that you have at the end of your formula. So in this case, if I want to find B, that means I know at the very end I'm going to have cosine B. That means I need to have side B be the leading side. Which of the numbers up there represents side B? 25. So I have to start with that side. Okay, so 25 is going to go first in my formula. So I'm going to write 25 squared. Okay, we're going to plug everything else in how we've been learning how to do that in the past. It's just that this is what I'm going to begin with, my little b. So what should I put in for the next two pieces? 12 squared and 15 squared. And you can put parentheses around these numbers too if you feel like there's a lot going on. Maybe you're afraid you're going to get an exponent confused for a whole number. Okay, minus 2. What two numbers should I put after the minus 2? Good, 12 and 15. And then instead of saying cosine of an angle, I don't have angle B, so I need to write it as cosine capital B, because that's what I'm trying to find, is the angle. Now in this case, we cannot just go straight to our calculator here. When we did the side angle side case up above, we could just type in this big long sentence into our calculator and then square root that answer like we did on our bell ringer today. I can't do that here because I don't have what B is, so there'd be a variable in there. We can't just type in variables in our calculator. Okay, it doesn't work like that. So we will have to maybe simplify what we can and start moving things around a little bit. So I'm going to start by squaring the numbers. So what is 25 squared? 625. What's 12 squared? 144. 15 squared? 225. Good, 225. Okay, now we're going to take that negative 2. So this is still going to be minus here. So you don't really have to think about the negative if you don't want. Just pull that minus down and then take 2 times 12 times 15. What does that come out to be? 360. And then it still says cosine of B. All right, my goal here is to get the cosine of B by itself because that's what I'm trying to solve for. I want to get that angle kind of isolated. So I need to move all those numbers over to the other side. So if I just look at these first two, the 144 and the 225, you could add those together if you wanted to, but how would you move them to the other side? What operation would happen? Subtraction. So I'm going to end up taking 625 minus whatever the 144 and 225 is. So you could add those together and then subtract, or you could subtract them individually. If you do that, what do you get? 256. And then that's still going to be equal to negative 360 times cosine of b. Don't forget about that negative sign there, because it's important. If we forget it, we're going to start working with like the wrong next piece here, and it's not going to give you the right angle. All right, what operation is happening with that negative 360 and the cosine of b? So how would I move that negative 360 over if they're being multiplied? We would divide it. So I'm going to divide both sides by negative 360. So that crosses off these over here. That's how I get my cosine of b by itself. Okay, and then on the left we need to divide. And you're going to get a decimal here. So it's okay if we want to maybe round it. What did you guys get? What follows the 0.7? One repeating. So negative 0.71 repeating. I'll just write it as negative 0.71. Since I'm trying to find an angle, though, what's the last step we need to do?
Is it like the inverse sign or whatever?
Yeah, but instead of inverse sine, what are we going to use this time? Inverse cosine. So we're going to do, to find angle B, I need to do the inverse of cosine, so cosine to the negative 1, and I need to type in that negative decimal. Okay, and you can round it still, or at this point, like if you still have your decimal in your calculator, you maybe were taught last week, like you can hit your second cosine and then hit second again and get your answer, and it'll just populate that decimal in for you. What do you get though for an angle here? 130 what?
135.
Point. What'd you say? 2. If they wanted it to just a whole number, then maybe we would just say 135. Okay. So I'll just write next to that. I would also just take 135 degrees. Again, if the problems are specifying how to round, if they want you to round it to the nearest tenth or the nearest whole number, make sure that you're rounding it appropriately for what they're asking. Okay. But that's going to be your final answer there. Now, just to let you guys know, at this point, they could then start to say, all right, now that you have an angle, find everything else in the problem. And then once you find an angle, you could maybe go back to law of sines. You are not stuck to using one of the laws for the entire problem. So there's going to be times where you're given a triangle, like this one, let's say, and they want you to find everything about it. You may have to start with law of cosines, and then you could eventually work your way to using law of sines. Law of sines is a little bit simpler as far as how it's set up. There's a lot less math that has to happen with law of sines. But you could still use law of cosines for everything if you wanted to. I could find all 3 angles using law of cosines. It just might take me a little bit longer than if I switch gears to doing the other law. And then once I have 2 angles, it's really easy to find the third one because you just add them and subtract it from 180 on a triangle. Okay. Do we have questions on that side case? Okay, so what I'm going to do right now is give you guys a homework assignment, but I am going to have, let me see here. Yeah, I think we're just going to go to the homework.